All right, here's a few problems from Chapter 5. This is problem 5.5.27. They ask us to factor, and they give us this problem, this trinomial right here. And if you remember from the factoring flow diagram, first thing we're always going to ask ourselves, is there a greatest common factor? And if yes, we're going to factor that out. You do see a greatest common factor in this problem. All of these terms share a b in common, so we're going to do that first. We'll take that out, and we'll be left with b squared. In order to get the b cubed back, we would need a minus 6b and then a plus 9. Okay, and then, with these trinomials in this section, they actually, give you this formula, the trinomial squares formula. And I don't think you need to use those formulas. I think you can just factor these trinomials like you would factor any trinomial. And I always use the trial and error process. So if we use trial and error here, we would just put a b and a b in these locations so that we get b squared back for the first. And then for the 9, I'm going to split it up into 3 and 3. And then I can see for the outside here, that would give me 3b. The inside would give me 3b. And then I want to think about what signs can I put here to get a negative 6b. So if I made both of these negative, that would work for my middle term there. Okay, so put negatives here, and if I check the last, negative times negative is positive, so that works. Okay, so that would be the factorization for that problem. Another question that was asked was this one right here, 5.5.35. And they ask us again to factor. Well, one of the first things that we need to do in these problems, always look for a greatest common factor, but the second thing you need to do is write them in descending order. So if I rewrite this problem in descending order, then my 49b to the fourth goes first, my 14b squared is second, and my plus 1 is last. Okay, and then again, I'm just going to treat this like I would treat any trinomial. I'm just going to factor it using the trial and error process. And for the 49, I'm going to split that up into 7 and 7, and the b to the fourth into b squared and b squared. Okay, now there are other options obviously for 49. You can use 49 and 1, but I think 7 and 7 is going to be closer to what I need because I'm trying to get a 14. So the 1 here I'm going to split up into 1 in that location and 1 in that location. And if I check my outside now, that gives me 7b squared. And my inside is also a 7b squared. So again, we're thinking about, can I choose signs for these numbers in such a way that I can get a positive 14 out of them? And I can make both of these positive. And then what I need to do when I put these positive signs in here is check and make sure that this works for the last. The last portion of FOIL is what I'm talking about. So if I take a positive 1 times a positive 1, and I do get a positive 1. So that works. And by the way, I didn't mention this on the last problem, but your book and sometimes the online program might do this as well. This is actually a quantity squared when you have the same term twice, and they may want you to write this answer this way. I'm not sure how they're wanting that on the program. I don't care. You can leave the answer here or you can leave the answer there. And, in the previous problem, we would write the answer b minus 3 as a quantity squared. Not sure which way they're leaving it. So either way is correct. Okay. Okay. And then the last problem asked for today was this one right here, problem 5.5.69. And you're asked to factor. You have 72c squared minus 50. Okay, so remember, the first thing that you're always doing is their greatest common factor. And in this problem, yes, there is. So we're going to factor out the greatest common factor. There's a factor of 2, at least, I think, that I see. So when we pull out the 2, and I believe we're left with 36c squared, and then minus 25. Okay. And then you're taking a look at the inside, and notice that that has 2 terms to it. And if we go down our flow diagram and we ask ourselves, how many terms are there? 4, 3, no. We go down to 2 terms. Yes, there's 2 terms. And we're trying to see, does it fit one of these forms right here? Okay. And yes, it actually is going to fit this difference of squares form, this first one right here. So what I'm going to do is try and write it in that form, a squared minus b squared. Let's see, let me write this over here. A squared minus b squared factors into a minus b and a plus b. Okay. So if I can write this in that form, then I can identify a and b and then just stick them into the formula. So what I want to do is I want to think about how can I write 36 as something squared? Well, it's 6 squared, and then I've got a c squared, and then for the 25, that's the same thing as 5 squared. Okay, and I can actually write then this as 6c, the whole thing being squared, minus 5 squared, because this is actually an exponent rule from Math 96. We're just using it in reverse here. We're saying that if you have the square of a product, two different things that are squared and they're being multiplied, you can just bring them together and have them on the outside with an exponent of 2. So in this particular example now, a is 6c, so the a is the a squared from my formula. I want to take a look at what's being squared in order to identify a. So you can see that what's being squared here is the 6c, so I'm going to call 6c my a, and 5 will be my b. And once I've identified those pieces, then what I do is I just stick them into this formula. Everywhere there's an a, I stick in 6c. Everywhere there's a b, I stick in 5. Okay, and notice that I'm carrying my greatest common factor along the whole way. So this is going to factor into 6c minus 5 and 6c plus 5. And that's it.